Lesson 7-1, solving inequalities by using addition and subtraction. And in this lesson, you learn to solve inequalities by using addition and subtraction. Why is it important? Because you can use inequalities to solve problems involving nutrition and personal finance. Let's take a look at this real-world application in nutrition. In 1990, the U.S. Department of Agriculture issued new dietary guidelines. These guidelines recommend that people greatly reduce their fat intake. Your recommended calorie intake depends on your height, desired weight, and physical activity. The average 14-year-old is 5 feet 2 inches tall and weighs around 107 pounds. Boys should consume about 2,434 calories per day, and girls 2,208 calories per day to maintain this weight. Okay, and so we can see the chart here. It's not very clear, but I'll just read it for you. This is actually snack. Okay, and this is quantity, and this is a cheese and peanut butter crackers. Okay, and this quantity is 9 crackers here, and this is whole roasted almonds. Okay, and there are 10 here, 10 almonds. Candy bars, and there are 2 candy bars here, and apples. Okay, 2 medium apples right here. Okay, and so that's our chart. And let's see what this has to do with anything. Oliana learned that in health class Oliana learned in health class that no more than 30% of her calorie intake should come from fat. Okay, for her 2,030 calorie a day diet. That means no more than 68 grams of fat. She keeps track of her snacks for one day and records their fat content as shown in the table above. So how many grams of fat can Oliana have in other foods she eats that day and stay within the guidelines? So this is Oliana's chart. Okay, and then let's reread the problem. Okay, so that she learned that no more than 30% of her calorie intake should come from fat. Okay, so that her allowable calorie intake a day for her diet is 2,030. Okay, that means she cannot take more than 68 grams of fat. So the question is, how many grams of fat can Oliana have in the other foods she eats that day and stay within the guidelines? Okay, so let's write an inequality to represent the problem. Let G represent the remaining grams of fat Oliana can eat that day. Okay, so if we use the chart above, the grams of fat in snacks would be 15 plus 8 plus 4 plus 2, because that would be 15 grams for cheese and peanut butter crackers. Okay, 8 grams for whole roasted almonds right here. This is 8 actually, write that here. And 4 grams for candy bars and 2 grams for apples, and that's where you get 15 plus 8 plus 4 plus 2. Okay, so the grams of fat in snacks plus the grams of fat remaining, which we represented as G, should be less than or equal to, okay, 68. Okay, so our inequality would be 29 plus G is less than or equal to 68. Okay, so the symbol less than or equal to indicates less than or equal to. Obviously, it is used in this situation because the total number of grams of fat in Oliana's diet should be no greater than 68. Okay, the word no greater than indicates it should be less than or equal to. If this were an equation, we would subtract 29 to each side. Can the same procedure be used in the inequality? Okay, and we will solve this. We will solve this in example number 1. So let's before we answer that question, let's look at this one. Let's explore what happens if inequalities are solved in the same manner as equations. We know that 7 is greater than 2. Okay, what happens when you add or subtract the same quantity to each side of the inequality? We can use the same number lines to model the situation. Okay, so if we add 3 to each side in 7 greater than 2, that would be 7 plus 3. Is it greater than 2 plus 3? Yes, it is, because it is 10 greater than 3. Okay, and if we use a number line for 7 greater than 2, this is what it looks like. And then if we add 3 units to each side of the inequality, okay, you'll end up with 10 greater than 5. And let's say we want to subtract 4 from each side of the inequality. Again, 7 greater than 2, and we subtract 4. Is it equal to 2 minus 4? Okay, so we look at our inequality. 7 is greater than 2, and we subtract 4 from 7, and we subtract 4 from 2. Okay, and if you notice at the end of it, okay, it is still the same. 3 is greater than negative 2. So in each case, the inequality holds true. These examples illustrate two properties of inequalities, and here they are: the addition and subtraction properties of inequalities. For all numbers a, b, and c, the following are true. If a is greater than b, then a plus c is greater than b plus c. Okay, so a plus c is greater than b plus c, and a minus c is greater than b minus c. And if a is less than b, then a plus c is less than b plus c, and a minus c is less than b minus c. Okay? And these properties, okay, these properties are also true. So go back here. Okay? So these properties are also true. I think there you go. These properties are also true when greater than and less than are replaced by greater than or equal to and less than or equal to. So we can use these properties to obtain a solution to the application at the beginning of the lesson. So what it's saying is this: okay, this property can hold true even if it's less than or equal to as well. Okay, so they're true for these inequalities as well. And now we can go and solve the example, or the problem at the beginning of the lesson. We want to solve 29 plus g is less than or equal to 28. Okay, so first things first, we copy the problem. 29 plus g is less than or equal to 68, and then we want to undo 29 by subtracting 29 to both sides of the inequality, and we end up with g less than or equal to 39. This means that all numbers less than or equal to 39 will be the solution for this inequality. So the solution can be written as all numbers less than or equal to 39. Okay? Now the brackets are important, because later on we'll find out that is what we call the set builder notation form. So how do we check this? We want to find, okay, a number less than 39 and a number that is equal to 39. So to check the solution, substitute 39, a number less than 39, and a number greater than 39 into the inequality. Okay, so let g be equal to 20. 20 is a number less than 39. So if we let g be equal to 20, substitute the value of g to the inequality, we end up with 29 plus g less than or equal to 68. Okay, and we find out that 49 is less than or equal to 68. So this inequality is true. Okay, and let's see if g is equal to 39, because it says it's less than or equal to 39. So if you look at that one, substitute the value of g to the 39 to the variable g, we end up with 68 is less than or equal to 68. That too is true. Okay, so we substituted two values for g that are less than or equal to 39. So now let's substitute a value for g that is greater than 39, which is 40. So if you let g be equal to 40 and substitute the value of 40 to g, we end up with 29 plus 40. Is it less than or equal to 68? No, it's not, because 69 is not less than or equal to 68. So that particular statement is false. So in this case, we've checked our answer. Eliana can have 39 and fewer grams of fat in other foods that day and stay within the the dietary guidelines. Okay. So the solution, okay, in example 1, was expressed as a set. A more concise way of writing solutions, a solution set, is what we call a set builder notation. Okay, the solution in set builder notation is when you have the bracket G and then a bar and then another G less than or equal to 39 close bracket. You read this as the set of all numbers G such that G is less than or equal to 39. So you guessed it, your answers when you do your exercises should be in set builder notation form. Okay, so in lesson 2-4, you learned that you can show solution to an inequality on a graph. The solution to example 1 is shown on the number line below. So this is the solution for example number 1, a closed dot on 39, and going to the left, since it's less than or equal to, it's a closed dot, okay, and it's pointing to the variable, therefore it goes to the left. Okay, so the closed circle at 39 tells us that 39 is included in the inequality. That's why it's a closed dot or a closed circle. The heavy arrow pointing to the left shows that it also includes all numbers less than 39. Okay, so if the inequality was less than, the circle would be open, or what we call an open dot. Okay, so you've learned this before, so we'll find out how we can use the closed dot and open dot situation. Okay, so let's take a look at example number 2. Okay, solve 13 plus 2z less than 3z minus 39, then graph the solution. Okay, so first things first, let's copy the inequality. 13 plus 2z less than 3z minus 39. Okay, and just like an equation, we want to isolate the variable on one side of the equations. In this case, it's an inequality. Okay, we want to isolate the variable on one side of the inequality. We want to undo one of the variables. In this case, we want to undo 2z by subtracting 2z from each side of the inequality. So when we subtract 2z from each side of the inequality, we end up with 13 less than z minus 39, and we simply add 39 to both sides of the inequality. We end up with z is greater than 52, or 52 is less than z. Okay, so since 52 is less than z, is the same as z is greater than 52, the solution set is z such that z is greater than 52. And the graph of the solution contains an open dot or an open circle at 52, since 52 is not included in the solution. And the arrow points to the right, and this is how it looks like. So an open dot on 52, and it points to the right. Okay? So what verbal problems containing phrases like greater than or less than can often be saved? So verbal problems containing phrases like greater than, less than, can often be solved by using inequalities. The following chart shows other phrases that indicate inequalities. The less than inequality, okay, can be represented by less than or fewer than. The greater than inequality, the phrase greater than or more than. The less than or equal to inequality can be represented by the phrases at most, no more than, less than or equal to. And finally, the greater than or equal to inequality can be represented by the following phrases: at least, no less than, greater than, or equal to. Okay, let's see how we can use that particular chart to answer this example. Alvaro, Chip, and Solomon have earned $500 to buy equipment for their band. They have already spent $275 on a used guitar and a drum set. They are now considering buying a $125 amplifier. What is the most that they can spend on promotional materials and t-shirts for the band if they buy the amplifier? So think of the word most, okay, and think of what inequality will be used with that particular word. So at most means that they cannot go over what is left of the budget of $500. They have spent $275, so they have $225 left. So let M be equal to the amount of money for promotional materials and t-shirts. Okay, so that's the case. The total to spend will be 125 plus M. Okay, is at most. Okay, at most is the inequality less than or equal to, okay, 225. Okay, and we want to solve this inequality now. Okay, copying the inequality, and then we want to solve this inequality by isolating the variable, subtracting negative 125 to both sides of the inequality, end up with M is less than or equal to $100. Okay, so the members of the band can spend $100 or less on promotional materials and t-shirts. And if we check our answer, if we add 275 plus 125 plus 100 equals 500, Alvaro, Chip, and Solomon can spend $100 or less on promotional materials and t-shirts. Okay? And finally, let's take a look at the last example. When solving problems involving equations, it is often necessary to write an equation that represents the words in the problem. Okay, this is also true of inequalities. So write an inequality, okay, for the sentence below, then solve the inequality and check the solution. So 3 times a number is no more than the difference of twice that number and 3. So let's look at this. 3 times the number will be multiplication, is no more than will be your inequality. Difference will involve subtraction, okay, of twice that number and 3. And this is how it's going to look like. 3 times the number would be 3x. Is no more than, okay, will be greater than. Sorry, it's not no more than. Is more than will be greater than. Twice the number, which is 2x. The difference would be subtraction or minus, okay, 3. So your inequality would be 3x, okay, greater than 2x, okay, minus 3. Okay, so we solve that inequality by subtracting, undoing 2x to both sides, okay, variables on both sides, and we subtract 2x on both sides, so end up with x greater than 3. So the solution set is x such that x is greater than negative 3. Okay, and the secret word for this problem will be saints. Again, the secret word will be saints for this problem. And that's the end of our lesson. Thank you for watching.